Person throws a rock upward. He is able to catch the rock back at the same level where he released it after 3 seconds. At what speed did a person throw the rock? So remember that when an object is thrown upward and lands at the same point where it was released, the initial velocity is equal to the negative of the final velocity, or you could say VI is equal to negative VF, or VF is equal to negative VI. Let me explain that further. So if I will have an object here and I'm throwing it upward, say for example the initial velocity of the object is 5 meters per second. It goes up and then reaches a maximum height, and then it goes back down to this same level. The velocity of this object here is equal to the negative of the velocity when it was released. So can you tell me what its velocity now, final?
No, negative 5.
That is negative 5 meters per second, because the object is going down and velocity is a vector quantity. So the fact that it's actually going down, that's why we put the negative sign right there. And also I have given it in this problem. When an object is released and lands on the same height, its final velocity is equal to the negative of its initial velocity. Now we would use this concept to solve the problem. Let me give to you the equations of motion. So we have VF is equal to VI plus AT. We also have the equation delta X is equal to VIT plus 1/2 AT squared. And finally, we have VF squared is equal to VI squared plus 2A delta X. Remember that since we are talking about free fall, so our acceleration is just equal to acceleration due to gravity, which is equal to negative 9.8 meters per second square. Going back to the question, what should we solve for in this question?
I think it's the
Initial velocity.
All right. If we look at the problem, at what speed did the person throw the rock? So meaning to say, we need to solve for this velocity right here, big or initial, because this is the velocity at which the person throws the rock with. So initial velocity. Now, what are the things that we are given? So once again, let me write that down. We need to solve for initial velocity. What do we have in the problem? What else do we have in the problem? What is given?
The problem you have the time.
All right, what is this?
3 seconds.
That's 3 seconds. So we have time, which is 3 seconds.
Yes.
So what is this time? It is the time for the rock to go from this point. It goes up and then back down to the same level. That is the time. Now, we need to solve for VI. We only have time. We don't have anything else in the problem. But we do know that the final velocity is equal to the negative of the initial velocity. Therefore, we cannot use any other equations in this problem because nothing else is given. We cannot use the second equation. We also cannot use the third. Say that again.
Why you can't use the second equation? Because it's half distance.
What's the distance?
No. We do not use this because it's half distance. Yes.
We don't use that because we don't have distance in the given.
Yes. Okay.
And that means we also cannot use the third equation because the third equation also uses distance on it.
Yes.
All right. So therefore, we are left with the first equation. This is what we need to use. Now let us substitute the values. So we understand that VF is equal to negative VI. Then I'm solving for VI, and I'm solving for VI. Then I could just say, instead of writing VF, so this is how I would want you guys to solve, by the way. So VF, I'll start with my formula. VF is equal to VI plus AT. Now my VF, once again, is equal to the negative of VI, and I need to solve for VI, so I could say instead of writing VF, I will have negative VI is equal to VI plus my A is negative 9.8, and then instead so I'm gonna substitute T with 3. Okay, now using your calculators, I will have VI, so I'll divide this by negative 2. I'll also divide this by negative 2. VI is equal to, can you give me the answer, please?
Mr. The answer is 14.7.
14.7. And what is the unit?
Speed, so it will be meters per second.
All right, meters per second.